Well, first, thank you all for being here. It's a huge pleasure to be able to discuss these things with you. zkVMs have become a core part of different parts of this of the rollup stack, and so I wanted to discuss some things. So first, I would like you to introduce yourselves and tell me a bit about what are the main design goals and advantages of your specific zkVM.
Yep, I'm Porter. I work at Matter Labs, one of the core contributors of ZKsync. I'll talk about our upcoming zkVM, Boojum 2. And some of the things we're excited about are like the Mersenne Prime, some of the work from like Circle Starks and 2-for-1 FFTs. I think this will be like a big boost for our users and making like separating the like proof system from the execution is actually very nice on the code side too. So there's a lot of reasons we're excited to have our own zkVM.
Hi, I'm Mami. I'm an engineer. Did it work? I'm an engineer at Valida. So compared to most of the zkVM, we built our own ISA. We finished optimizing a compiler so we can compile C, Rust, and since a month ago, WASM. We're adding and releasing next week client-side proving. And so what we want to do is build a customizer that we don't think RISC-V is the best one, and offer that so that blockchain proving is super efficient, super fast. I don't know if it can be done on phone yet, but we'll try to.
Hello, everyone. I'm Stefan from the ZKM. ZKM is a MIPS-based ZK virtual machine, and MIPS is I would say the most consistent. It has the most developed ecosystem, and in ZK MIPS we employed like in current implementation we use Planck 2, and after next month we will announce our ZK MIPS Plus. It's built on the Planck 3, and it's brings about 6 to 11 times faster than current implementation. Yeah, thank you.
Hi, I'm Muthu, CEO and co-founder of Ligero. Our main design goal is useful and usable privacy goals. I want to say that this is in line with the philosophy of zkVMs. zkVMs want to make designing ZK applications easy. We want to make designing privacy applications easy. We are also a zkVM, but we go against the grain on many of the things. Our VM is based on WebAssembly, and maybe we could have a panel on WebAssembly versus RISC-V. I'm sure that'll be interesting too. But our focus is really memory efficient. The gentleman asked this question at the end of the keynote. Actually, our tech is really right there. We have the same code base that can run from a browser of your mobile phone, but also can run on an H100 or A100. You wouldn't need that, but it's the same code base, and it will scale nicely when you give hardware.
Well, thanks a lot. It seems that we have like very different design choices and also objectives. So something that we currently see is that performance has been like consistently improving. In fact, Porter mentioned that we've been getting like 10x every year, more or less, from changes in proof systems or other technologies. Okay, so I'd like to ask you, what are the current bottlenecks in zkVM performance, and how do your different zkVM architectures approach such trade-offs between, for example, proof generation time, recursion, memory efficiency, etc.? It would be good to talk about it.
Yeah, I'll say like our goal is to run like L2 blockchains for our users, and so we are choosing the hardware that's like the cheapest. If we wanted to like hit performance benchmarks for like as fast as possible, we could use bigger machines. We're not trying to do that. I'll say one performance bottleneck for us that's specific is that the like PCIe connection between the CPU and the GPU is actually like a bottleneck and too slow. we've been doing witness generation on the CPU and then sending all of that data to the GPU. And it's like not getting there fast enough. So with the next version of our proof system, we're moving witness generation inside the GPU so that we don't have to like be bottlenecked by the speed of between the chips.
You stole my thunder. Like witness generation is everyone is optimizing for proving speed, but witness generation is quite slow. And I guess the other thing is that FFT is a memory-bound algorithm. Porter mentioned in his previous talk, sum check everything. So this is something we're considering because it removes the need for FFT.
I think currently we have two bottlenecks. The first is, given that our objective is to implement the real-time proving, the first is the stack to snack proof compression. Although we know that from some experiment tests, we found that it may take about like 40 seconds, maybe to prove the stack will fire by the group 16. Okay, so I will know 12 seconds a block. So we may need to, maybe reduce the query proof from the stack, or we leverage some like hardware acceleration for the group 16. Yeah. The second one is the mentioned the proof the trace generation. It's happening on the CPU, and we try to because zkMIPS is a universal for the general purpose computation. So that means no matter what kind of computation we have, we need to compare it to MIPS, and then we generate trace in the MIPS emulator. So in this part, I think MIPS have a big advantage than the RISC-V because we have about 70 instructions, including the complex instruction like the mar-add. So I believe it can significantly reduce the trace length, but still we also needed to split the trace into many trunks, and then we use a decentralized cluster to prove that. So I think in summary that we need maybe a pipeline proving architecture to make sure that the computation can distribute and be like finished in parallel.
Maybe just to say something cheesy, I'll say we don't have any bottlenecks, but there is a little bit of grain of truth into that. The Ligero system is neither start-based nor sum-check-based. So we can do recursive composition, but we don't need recursive composition. So if you ask for bottlenecks in recursive composition, we don't have that. But I want to say, and of course I agree with my fellow panelists in terms of CPU, GPU, and witness generation. I want to say to be memory efficient, if you have several rounds of interaction in your protocol like sum-check, you would have to do witness generation that many times. In Ligero, actually, you have to do it 3 times. And so any improvement in witness generation is going to improve our system. And we will still keep it. We always want to be memory efficient. But maybe just in terms of bottlenecks, since we have covered most of it, what I'll say from our perspective, the bottleneck is about bringing optimized circuits into zkVMs, right? I mean, there are precompiles. We're going to have this discussion later. But just in terms of bottlenecks, I want to say that we're going to integrate CirCom, which means that all the beautiful circuits that are built on CirCom can be embedded as a WASM module when we compile things. So, and we want to bring in the circuits that's been done in Cairo, in Noir, etc. And I think there are going to be challenges in doing this in an efficient way.
Yeah, I've been talking with several other teams also on the bottlenecks, and they all seem to point out this thing of the witness generation and in general trying to move like to GPU native, for example, zkVMs. Of course, that is if you want to prove really large computations and you don't care about like client-side proving. Of course, something else that I think has to do with the overhead that we had with the representation of the different variables inside the VMs, we've seen that we started with very large fields, and then we went like smaller and smaller. Still, I think that Baby Bear or Mersenne sometimes still have like some overhead. I don't know, maybe I'd like to see something more related to also binary fields. Let's see what we have, but it's super interesting. But it seems that everybody's pointing more or less on the same direction. But I don't know if you want to do any comments or discuss something.
So I can comment on the binary fields. Benius has been a big name all of 2024, kind of the dark horse of the proving systems. Why? Because a lot of bottleneck in Ethereum is hash function, Keccak for the Merkle tree, and binary field XOR and so exclusive OR is basically a plus in a binary field, and binary field are super efficient at representing this. The thing is, the other major cost is elliptic curve signature verification, and here a small field or a big field is very efficient as well. So the jury is still out there between I guess small fields and Benius.
I just have probably a little bit of a different take. One of the things that we've done in Ligero is be able to bring all the optimizations, the cool optimizations done in other systems. Let it be lookups, let it be precompiles. This is something we can bring in. I want to say, I actually sit across, I'm a professor at Georgetown, I sit across from Justin, and we have this conversation all the time about big fields and small fields. Our current implementation actually is a big field. And I don't want to say that it's not the bottleneck right now. Of course, we could get 20x faster if we move to a small field. But I also want to sort of project into the future. One of the things we could do in Ligero is take all the parts that are good on binary fields, do it on the binary field, and do all the things that are good on large fields, and then just do a connector between them at the composition step, right? And I think philosophically, I think this is going to give us the best performance.
Yeah. So some years ago, we only had the one VM. We started with the Cairo VM, and then we've seen like several projects spin off. But now we have even more with multiple zkVM projects emerging. How can we work towards interoperability and standardization? Do you see a future where zkVMs converge towards a single standard, or will different zkVMs specialize for different use cases? What is your take?
So a lot of the zkVM out there are already using Plonky free, and there is a GitHub issue to discuss, should we create a universal Plonky free Stark verifier? So there are efforts into trying to create a standard. I'm not sure, like, everyone is busy trying to find product market fit and a use case, because this is a lot of resources invested. So I'm not sure if the standard will be created right now. But on the other hand, the Ethereum Foundation has been sponsoring ifproofs.org to compare everyone, has been sponsoring formal verification effort for all the zkVM. I feel like there is something, but I'm not too sure if it will realize into a standard.
Yeah, I totally agree about that. So we may have a standard for the Plonky. Not only the modular proof system, modular field, modular hash functions, but also the the proof recursion. Maybe the standard stack to stack. Proof aggregation, yeah. So this, I think this can make it easy for different projects to have a more secure, more scalable proof system. Yeah.
Yeah, just add as a formerly or currently slightly unaligned, non-standardized EVM, moving with the standard is a good idea. And so I think that the field's moving really fast right now. So it's maybe a little too early to like standardize some things, but in the long run, yeah, it'd be great.
I feel like I got up on the wrong side of the bed because I'm going to say something different. We were part of a federal grant to scale zero knowledge. We worked 4 years. There were 10 teams. One of the goals was to agree on a VM. And after 4 years, we agreed on R1CS. And if you didn't get the joke, come and ask me later. Agreeing on a VM is going to be hard. But I do think there are things that can be agreed upon. All VMs want to make developer experience easy. We could agree on the pre-compiles or even the API calls at the C, C++ Rust level. This is something that I think the teams could agree on. This is, again, it's not heavyweight, it's easy. On the other end of things, I also think that verifying the last step, like maybe how these things are verified on-chain, which also probably matters a lot, could also be something that the different teams can agree on. That being said, I'll say that I started, along with some of my colleagues, the ZK proof standardization. We have the 7th edition next month, so please look up and come. We are discussing precisely these topics.
Okay, that's really nice. I am going to jump to a different question since we've been talking a little bit about standardization and all that, and something that really matters is security. Okay, so what are the biggest security issues associated with zkVMs today, and how do we ensure that zkVMs implementations remain verifiable, auditable, and secure? Okay, it's something that I think we all care and would be nice to discuss.
I think the past 9 months has been all about breaking Fiat Shamir. So we had one big paper in July and another one a month ago. I think two issues with Fiat Shamir a month ago. So this makes, I guess, efforts around format verification, the funding by the EF announced 30 million funds to help secure and review zkVM. Like, I guess many people think cryptography, it's math, it's easy to secure, you have equations, everything is solid, but the truth is, it's still a new field. We're engineers, and just like we had SIDH or SIC, like isogeny-based cryptography being broken, even though we had experts with 10 to 20 years of experience building them, we're still learning.
Yeah, I think there's bugs at all parts of the stack right now. Like there's bugs potentially in like the cryptography theory with Fiat Shamir. There's bugs in like some of the papers. There's bugs in like some of the implementations. There's like all kinds of places where these things can go wrong and have gone wrong. Like just read through all the security audits from all the zkVMs. Another challenge is that zkVM code bases are very large, like hundreds of thousands of lines, which makes it very difficult for like a single auditor to audit the entire thing. At ZKsync, we've often had like an auditor audit like one piece of the zkVM, and then we have to like kind of hope that all the pieces are working together. We've had big audits too, but it's a tricky part.
Yeah, security is always the first, I think, for the zkVM. Yeah, maybe just a week ago, somebody found out vulnerability in Planck 3, right? And so it also affects most of the Planck 3-based system, zkVM or ZK, application-specific sockets, something like that. Okay, so for the zkVM, actually, the conjective security is very, very, important to maintain, including the proof recursion, lookup, and even the hash function. So here, that's why I think it's important to have a standard for the Planck 3 proof recursion and something and the basic, blocks to build a zkVM. Yeah.
There is two components of zero knowledge proofs that make auditing challenging. There is the cryptography part. You want to prove the soundness and zero knowledge for things that have privacy. You want to prove them first from a theoretical standpoint that it meets those goals, and your implementation are consistent with what you theoretically showed. And the second are just bugs in your code, right? And there is also sort of an intermediate where you need to have expertise in both these areas, right? So if you're thinking about a PhD in cryptography, please go ahead, right? This is going to be very important. But when I come to, I mean, Ron Rothblum's and his colleagues' result on Fiat Shamir, etc. First of all, Ligero is not vulnerable to that. I just wanted to make a point. But more importantly, I want to say that I don't think we should fear that too much. We do want more people thinking about it. We do want to strengthen it. Fiat Shamir is not provable. It is a heuristic, right? It is a heuristic argument that allows ZK to be non-interactive. You cannot, you do have to make some kind of assumption to make non-interactive. Theoretically, you cannot have non-interactive. The point is that I would look at the Fiat Shamir issue that came up more like, hey, attacks on hash functions, right? Like this is going to be there because even hash functions, it's not like you can have a provable theory, but there has been wealth of information on trying to make it robust. And I think the same thing will happen with Fiat Shamir as well.
Yeah, no, that's super interesting. We know already that some people are also working towards formal verification of zkVMs, and this is an active area that we should all be working on. So jumping a little to applications, what are the most promising real-world applications of zkVMs today? Are zkVMs primarily suited for blockchain-based applications, or do they have broader use cases in verifiable off-chain computation?
Oh, they work very well for blockchains. I think one of the cool parts of ZK is you're proving, and you're like, so what this kind of solves is that you only need to maybe do the hard computation once, and in an untrusted environment that can be like very, very useful. So I've been saying I think there will be like thousands of blockchains, thousands of L2s. And in that world, I would rather just have proofs from everybody that they're doing things correctly, and that is probably the only way I can possibly verify everything myself. So for blockchains, I think it's a great use case.
So ZK, you have two kinds of ZK. One where ZK is a misnomer. It's a succinct part. It's when you delegate computation to a third party, and there is a ZK for privacy. So far, at first, ZK was all about privacy, and now people are trying to push VVM for verifiable VM name. But for delegation, that's where we want to accelerate blockchains, and we can't because everyone needs to run the same computation. And with the zkVM or VVM, we can delegate. And this is something that we can see also on Web 2. You have Uber delegating to driver, Airbnb delegating to hosts. And now with the rise of AI, people are looking for compute everywhere. And it's possible that at one point, I don't know, Disney, Nintendo may want to infer some thing, but make sure that they don't infringe on someone else's copyright and prove that that was not trained on some artist from the internet.
Yeah, I think blockchain AI has been mentioned. For the zkMIPS, currently we are part of the God network. I mean, we are the infra of the God network. God network is the Bitcoin layer 2. So leveraging the zkMIPS to generate proof for the God network, and they verify it's on Bitcoin. Okay, so I believe not only for Ethereum ecosystem, but it's because it's a universal, ZK virtual machine, so it's kind of useful for all different blockchain. Another work we are focused on is the Metis new AI infrastructure just announced maybe 2 days ago. So we are trying to leverage using the zkMIPS to scale the AI to make sure that the execution of the AI agents is fair, and also use it to preserving the privacy of the people's prompt and response, to make sure that the agents works fair and it works and make people can trust the AI agents. Yeah, it's a good connection between. I believe a good connection between the Web 2 and Web 3. Yeah.
Coming last in this question is a bit hard, right? All the use cases have been kind of covered from blockchain to here. Maybe I'll tell just a little bit in terms of vision, right? I mean, if we are going to think, I don't know when this is, 5, 10, 15 years, the whole world is integrated in blockchain, then at some point, the whole world has to get on blockchain. We have not reached the whole world. Web 2 hasn't reached there. Enterprise hasn't reached there. I think this is going to be enabled only by zero knowledge, only through privacy tools. Enterprise are not going to come to blockchain where their clients' transactions are visible. Enterprise is not going to come onto blockchain where regulatory compliance is not there. I know we could all have differing opinions on regulation, etc. I believe in a world where we integrate everything, and once we do it, everything is automated in a way you get privacy. But I want to say that there are cool applications that are there, not just, I don't want to think just Web 2 or Web 3, where zero knowledge is used. Europe is moving into digital ID. Finally, we will have the ZK application that we all talk about of going into the bar and proving we are over 21 years of age. And there are like cool applications, and Aztec and the teams that are doing ZK email, ZK TLS, these are going to be crucial to bring Web 2 to Web 3. I mean, Zach said it really nicely yesterday in the keynote, if you all came, like how this is going to make the difference and how we are going to bridge the gap. I want to say that like Zcash, Mina, Aztec, all these things they started off with privacy, but now zero knowledge has also made inroads into scalability, which all these roll-up infrastructure is trying to do. Bridging these two is going to be important. I mean, we have independent L1s versus the ones with public L1s and all these things. Having a unifying these two is going to open up a lot of use cases.
Yeah, totally coincide. I think coincide with the ZKTLS thing. It's going to be crucial, and also bringing real privacy. This will enable us to onboard, as you say, many institutional operators and companies. So going a little bit further into the future, what further advancements in proof systems could significantly improve zkVM performance? And how do you see zkVMs evolving in the next 3 to 5 years?
I mean, as you mentioned, maybe Bennius and binary fields would be like a cool direction. I think a lot of us haven't switched over to that yet. I think also ZK hardware is interesting because maybe for some use cases, especially like the basic things like FFTs or multiscalar multiplication, that could be cool. So we'll see. It's hard to predict.
I don't know. Like things are moving so fast. If you want to keep track, you spend more time reading paper than writing code. But I expect that as some primitives become key for accelerating some workloads. So we had some hash functions, which kind of led to research around Bennius. Maybe tomorrow we want to accelerate matrix multiplication, and there are ways to do this very efficiently in linear time. It's in Justin's Haller book if you want to read it. I guess people will try to pick the workloads that they want to super optimize.
Yeah, I think one of the most important things we need to do in the maybe next 3 to 5 years is proving on your device. Yeah, like mentioned, Noah has trying to do that, but it's a specific application-specific circuit you need to build. But if you want to run any computation on device by the by the zkVM. Maybe all the zkVMs needed to reconsider their architecture proof system. Yeah, to make sure that the memory, the computing power are enough for the devices to prove.
All my colleagues are very modest over here. It's like, let me predict, everyone here will use Ligero. Okay, like keeping that aside, I think that at least my view, again, maybe this is very controversial. I think that small field, large field, ZKDSL, circuits, zkVMs, SumCheck, Starks, Ligero, I think that there are going to be different workloads that can take advantage of multiple components of each of these systems put together to get the highly optimized. As much as I want to say Ligero will do everything, I also will be open-minded to say that, hey, if a component in Ligero can be sped up by SumCheck or by, I don't know, just normal Halo or Groth16, we will consider it. I think that inheriting the best parts of all of these is going to give the best performance.
Okay, awesome. And this week we had a discussion, what's best, zkVMs or zkDSLs, for example, or zkLLVM. So what do you think? Will zkVMs eventually replace application-specific circuits, or will both approaches continue to coexist? What's your take?
I already answered that question in my previous, so I'll let...
Yeah, but you never start speaking, so.
So really the question here is between zkDSLs and zkVM, zkLLVM, the question is what is the cost of your arithmetization, right? With zkDSLs, what you're trying to do is for certain primitives through precompiles or whatever, you want to get the highly optimized circuit. I think there is a win-win doing both, right? Like I think you do build optimized circuits in whatever language, but you can inherit it in other ZK systems and then provide a uniform API. You can get, the benefit of a DSL as well as a VM. I think the more larger question, at least for us, is we want to make the privacy tool more usable, right? Like I think there's going to be phenomenal advancements made in both zkVMs and zkDSLs to get there.
I believe the end game is zkVM. Yeah. So as we say the zkDSL, we may measure the performance is good. Yeah, it's very, very good now today. But we have the pre-compares. The extremely pre-compare for zkVM is zkDSL, I think. So as we see that on this proof, we have we prove the EVM. But we can see that if you just compare the EVM or RAS EVM into MIPS or RISC-V directly, the sequence length we need to prove is very, very large, very, very large. So almost all the projects there, we use extremely pre-compares for the K-check, for the SHA-2, for the field operations. Yeah. So I believe the end game should be the EVM.
So there's a famous quote from Steve Ballmer, which was developers, developers, developers. And I think what matters is developer UX. And I want to make a parallel with the world of AI and Python. AI uses a lot of data centers in the world. People are building data centers, but they're still using Python, which is well known to be a slow language compared to C, C++, Rust. And why? Because it's the glue code between the high performance component, similar to how people are using Kubernetes for orchestrating everything. Python is used for that. And zkVM are the orchestrator between precompiles and very optimized components. I used to work at Tyco before. We wrote a ZK EVM with everything as a circuit. This is not sustainable, and we stopped and we switched to zkVM. Why? Because we wanted to be a type 1 blockchain but it's not possible if you have 6 months of audit every time the EVM is changed for an EIP to add something.
I'll have a different take. I think the challenge is that the EVM is changing all the time, so that's the only reason you can't write something very custom just for the EVM. I think zkVMs will dominate like the long tail, like 80% of like easier Python use cases. But I think for like really high production workloads, like look how much better these projects have gotten by choosing like their custom ISA or MIPS. I think like we have a project working on ZKsync called Space and Time that's written custom ZK for proving SQL queries, and they've gotten huge performance benefits from it. So I think for those like really high-end, high-throughput, like production-level code, people will always write custom ZK just for that.
Yeah, totally interesting takes. So I'd like to wrap with a last question, which is, what's the most overlooked challenge in zkVM adoption today?
Explaining what ZK is. Just teaching people the concept of we have this like weird thing, we can prove it, and there's math going on, and it does this for you. Like the whole world knows what AI is, but like even my parents can't really explain ZK. So I think I personally want ZK education to get like way better, and I think that would help a lot of our project's adoption.
So possibly a spicy take, but I think ZK is something somewhat bigger than blockchain, but people cannot even get blockchain. So how can they? They cannot even relate to what would ZK bring to them.
Yeah, I think the best education is let people to use some ZK applications that it's benefits for the people's daily life, daily transaction. Yeah, so actually that's our zkMIPS strategy. We call it vertical strategy. That we use the zkMIPS for God network, for Metis, for large AI. So we can build a real use case, a real world use case that for people to feel that, yeah, I'm using ZK. I feel I trust, because I trust ZK, I trust the mathematics, so I feel security about your product, your products. Yeah.
I agree with all my colleagues. Also, with what Porter said about telling people about zero knowledge. We've been building zero knowledge proofs and secure multi-party computation. If zero knowledge is hard, imagine talking about multi-party computation. I do think that bringing these applications client-side, like thinking about privacy applications, I think this is more approachable for people. Tell that this is a tool that will give you privacy. Tell them you can go to a bar without showing your driver's license and prove your ID. You don't need to reveal sensitive information. There is a tool that will make it seamless.
The issue is that government wants to put backdoors into secure messaging. So if people say, oh yes, we allow that, they don't care about privacy.
Yeah, well, I have my take. I think that also verification costs are an important thing, because you can have the tools, but then if you have to pay a lot of money to run your application, that limits the kind of things you do. So that's why I've started working on my thing. So send proofs, please. We need them. So guys, thanks a lot for having us, for having me and all of us here. It's been a huge pleasure. I liked a lot our conversation and hope to continue it off stage or sometime later. Thanks a lot for joining.
Thank you.